looking at this figure here. So अगर आप यहाँ देखें तो the maximum it goes is about 19% eutectic पे 19.7%, and this is about 3%, I suppose. Okay, this is 2.5%, not even 3%. So 19% and 3%, 19% in here, 3% in here. That means, sorry, 19% in here, 97% in here. This means 3.5 or 2.5% lead in this one. Now, if we look at this Loy, which is it's all liquid here, then at point 1, sorry, at point H, what we have is homogeneous liquid, then it reaches this point I, and this starts to solidify into a eutectic structure that is shown schematically over here. So this happens at a single point. So from the phase, from the phase diagram, you can see this is a point having a 0 degree of freedom. On line, this is 1, while in certain phases there is 2, and here you can see you move lot many compositions and things, the more freedom here. So when that goes just below this eutectic point, tectic. So how many morphologies do you see here? In this schematic, how many morphologies are shown? Or how many, what type of microconstituents or how many microconstituents are there? Are present or some gone?
Present, sir.
Yes, sir, present.
Okay. Okay, I'm audible?
Yes, sir.
Yes, sir.
Okay, so what kind of morphology or what do you see here? How many morphologies and how many phases? Quickly यार, ये तो हम डिस्कस कर चुके हैं. I don't know, मैं इस पे ज्यादा टाइम इसलिए भी लगा रहा हूँ कि आप में से वो लोग जिनका बैकग्राउंड नहीं है मटेरियल्स, तो we can drag them along, otherwise could have gone faster. Please, quickly, so that we can move forward.
The one type of morphology.
One type of morphology. Okay, Numan, what do you think?
One type, I think.
Okay. Okay, so we have eutectic. Okay, we have all eutectic. So alpha plus beta phases have different compositions than the original composition of the liquid. So this is given here, alpha and beta, and the liquid is 61.9% tin. This the whole composition, but alpha is having a different weight percent of tin compared to beta. Okay, so this is what actually it looks like. Okay, ये slide clear है सबको? Is it visible to all?
Yes, sir.
Yes, sir.
Okay, so look at this one. Okay, where come this composition lies? Okay, मैं इसमें कुछ लाइनें लगाता हूँ, आपने मुझे बताना है कि ये composition कहाँ बनती है. Okay, 1, 2, 3. अब आप बताएं कि ये जो आपको composition ये नजर आ रही है, स्ट्रीम लेफ्ट, ये जो आपको माइक्रो स्ट्रक्चर नजर आ रहा है, ठीक है, ये this is, let's say this is 1, this is 2, this is 3. Okay, sorry, 3 कुछ 7 लंबा हो गया. So 1, 2, 3 कौन सा स्ट्रक्चर है ये?
Sir, 2 है.
2 है?
Sir, alpha
ये
plus
two है.
liquid. Alpha plus liquid.
अल्फा प्लस लिक्विड है या रूम टेम्परेचर पे है ये? Obviously, you can image that at room temperature, but let's say this is something which is similar to this line 2 or this composition 2 where alpha, right? Primary alpha, you may call this primary alpha, and you may call this alpha forming at later stage, sorry, this one at later stage or secondary alpha, eutectic alpha आप इसे कह सकते हैं. So this is primary alpha, and in here there is eutectic alpha. And the other is beta. Okay. What about this one? Middle one.
Sir,
This one here.
this is the third one, sir. The point, the eutectic.
Okay, this is the eutectic. ठीक है, आपको सारा इसी तरह का eutectic phase नजर आ रहा है. This is all eutectic. Now, if you look at this one, this relates to this composition shown over here, this line here. So this is beta, primary
Plus
beta
eu-
form here,
Yes.
and then eutectic. Okay,
Yes.
ठीक है, आपको clear हो रही बात?
Yes, sir.
We have
Yes, sir.
alpha beta in the eutectic and there is primary beta. Alpha beta in the eutectic and then primary alpha. Okay, here there is no primary alpha or beta, it's all eutectic. Now, if we start from this side, okay, left side, so this composition range starting from this point to this point, this composition range is called hypoeutectic. Then this is eutectic and this is called up to this point hypereutectic composition. ठीक है, कुछ क्लियर हो रही बात?
Yes,
Yes,
sir.
sir.
Before the eutectic and after the eutectic. So you can calculate relative amount of phases, composition of phases. Okay, so just above the eutectic isotherm at any position C4, this one here, just above the eutectic isotherm, आप ये sorry, amount of eutectic निकाल सकते हैं. कैसे निकाल सकते हैं? By using lever rule and making a tie line here. ठीक है? Below the eutectic, you will use these lines. So primary alpha क्या होगा? In this range, Q over P plus Q. ठीक है? Alpha is this side, so Q over P plus Q, this will give you the relative amount. Total primary alpha, अच्छा, तो total alpha primary plus eutectic. So eutectic में तो यहाँ भी eutectic बनेगा. So that would be Q plus R divided by P plus Q plus R, total range. क्योंकि eutectic यहाँ भी बनेगा, eutectic यहाँ भी बनेगा. आपके पास तो रेंज सारी पूरी है ना, ये यहाँ से यहाँ तक आपको कोई सॉलिड लाइन यहाँ नजर नहीं आ रही इन दिस रेंज. टोटल बीटा, टोटल बीटा, बीटा कहाँ से कहाँ तक बनेगा? बीटा P ओवर P प्लस Q प्लस R. टोटल बीटा मीन्स बीटा इन यूटेक्टिक. ठीक है, अगर आप इस कंपोजिशन की बात कर रहे हैं तो बीटा इन द यूटेक्टिक, क्योंकि प्राइमरी बीटा होगा इस कंपोजिशन में. कंपोजिशन C4, will there be any primary beta?
No, sir.
Okay, so beta will all be in the eutectic. ठीक है, सो एक चीज आपने याद रखनी है कि जितनी भी हम ये डायग्राम डिस्कस कर रहे हैं, सो दीज आर ऑल इक्विलिब्रियम डायग्राम. ठीक है, तो अगर कोई if there is anything that takes it away from equilibrium, तो the structures might change. ठीक है, उसमें जो phases बनते हैं वो that might be different. और ये जो lines हैं आपको नजर आ रही हैं, the temperature lines और the composition lines, ठीक है, ये भी जो अपनी position shift कर सकती है. Right? So remember, this is under equilibrium condition. This diagram holds under equilibrium conditions. Okay, so here short range diffusion led towards one side, tilt towards the other, forming tin rich region, then lead rich region, so this kind of structure happens. ठीक है, आप देख सकते हैं कि ये लेवलर स्ट्रक्चर आपको लेयर्स की फॉर्म में ये नजर आ रहा है. Okay, so intermediate solid solutions that do not extend to pure components. So terminal solid solutions होते हैं, they extend to pure components, while intermediate solid solutions they do not extend to pure components. So this is a copper zinc diagram. So copper zinc diagram में terminal solid solution कितने हैं? How many terminal solid solutions? नुमान कितने terminal solid solution?
टर्मिनल सॉलिड सॉल्यूशन में
जी जी कितने हैं? How many? Can you name them? Okay, is it visible this copper zinc diagram?
Yes, sir.
How many solid solutions? Terminal solid solutions. Diagram आपके सामने यार it's easy.
The 5?
5 which ones?
The alpha, beta, gamma, eta, and this one more.
Okay. Uma, do you think these are terminal?
Yes, I think so.
The terminal are those which extend to pure metals or pure components like this one.
So then only 2 are there.
Only two, alpha and this beta.
Yes.
Okay, these extend to this pure
Yes, sir.
metal or pure component. Right?
Okay, sir. Right, sir.
So two. So how many intermediate? How many intermediate? Solid
So
solutions.
three.
जी बोले.
So three beta, gamma, and
Beta, gamma, and eta. Three.
epsilon.
And there are some combinations, but only three solid solutions. Okay? Here beta
Yes,
and
sir.
gamma exist. Here gamma and eta exist, but the intermediate solid solutions are only three. So these are terminal, these are intermediate. Okay, we have delta as well. Sorry, we didn't see delta. Delta here existing at higher temperature. Okay. So not existing at low temperature. This is existing at higher temperature. So again, we can use this lever rule to find out the number of so relative amount of phases and also the composition of these phases. This is upon
Recording stopped.